casually watching a video on YouTube, on a computer more powerful than anything humanity could build a few decades ago. This progress and all the wonderful machines you take for granted are built on a few rare and precious materials.
These materials have names like terbium, neodymium, or tantalum.
Getting these rare materials from the ground into your devices is not easy and often has negative consequences. The mining industry is responsible for air and water pollution, destroying entire landscapes. Dangerous chemicals are used to extract resources, harming biodiversity, workers, and locals.
Rare resources are also political tools when countries restrict access to them to get their way.
But what if we could replace the mining industry on Earth with a clean process that can't harm anyone?
We could.
And do it in space? Well, we can. All we need to do is look up.
Asteroids are millions of trillions of tons of rocks, metals, and ice, left over from the cloud that became the planets 4.5 billion years ago. They can be as small as a meter, or protoplanets the size of entire countries. Most of them are concentrated in the asteroid belt and the Kuiper belt, while hundreds of thousands more do their own thing between the planets.
As space travel is becoming more feasible, scientists and economists have begun looking at the resources found in these asteroids.
Even relatively small metallic asteroids may contain trillions worth of industrial and precious metals, like platinum. Bigger asteroids like 16 Psyche could contain enough iron and nickel to cover the world's metal needs for millions of years. At current market prices, the rare raw materials alone would be worth quadrillions of dollars. Well, not really, but technically.
There are over 20 million tons of gold in the ocean's water, worth roughly 750 trillion US dollars.
But filtering out the gold would be so expensive that you'd lose money selling it. Right now, asteroid mining has exactly this problem. It's too expensive to replace mining on Earth. Billions of dollars worth of valuable resources in space are worthless if it costs trillions to get them. What makes it so hard?
The basic idea is to choose an asteroid, move it to a place where it's easy to process, and then take it apart to turn into useful products.
Going to space is expensive. It costs thousands of dollars in rocket fuel for each kilogram just to reach a low Earth orbit. Going further out into deep space costs thousands more. We need cheaper space travel to make asteroid mining profitable.
It's not ideal. It's not ideal.
One solution is to switch from classical rockets to electric spaceships.
We already use electrical rocket engines for many of the space probes on science missions. In principle, we only need to build bigger ones.
While electric engines are not powerful enough to fly to space, they require only a tiny amount of fuel to go very far once they're in space.
This means we don't need to spend a lot of money on fuel, only to transport fuel into space. This doesn't solve the whole cost problem. Now that we have an electric asteroid mining spaceship, we need to find the right asteroid and get it there. Our first targets will probably be near-Earth asteroids, asteroids that orbit, well, near Earth.
After a few months of travel, our spaceship finally arrives at our asteroid.
The first thing that needs to be done is to secure the asteroid and stop it from spinning. There are multiple ways to do this, like vaporizing material with a laser, or stopping the rotation with thrusters. The Moon is useful because we can borrow its gravitational pull to put the asteroid in a stable orbit around Earth, which saves even more fuel.
The first space mining and processing equipment has been installed in orbit and is now carefully moving towards the asteroid. The processor works very differently than on Earth.
Giant mirrors focus sunlight and heat up asteroid rock to boil out the gases. Grinders break up the dried rocks into gravel